Be good. And we'll just give just a few minutes for people to join. Thank you all for joining us today. Um, Feel free to you're probably all like stuffing your faces with lunch, or you're simultaneously on a site visit, or
Hmm.
I don't know, who knows. It looks like we've got Dale here from oh, hi, how's it going?
Hello.
And we have a few of our DeepRoot folks, Sean and Dale, and I saw a few other people. Hey, Sean,
Hey, Chris.
Tony, there we go. Um, Amazing. So I'm just kind of I had doing a little bit of prep here on the workflow itself, but um, why don't I get started? Because I feel like some of these things, for folks who are here, your time is important and valuable, so we don't want to spend too long on these things. So I'll provide a little bit of context. I'm Chris Landau from Landau Design and Technology. Um, as I said, we're joined by Ben Summy from my team, Sean Friedberg from DeepRoot, Dale Butterfield from DeepRoot, Tony Slusser, and I think a few others, maybe. Not sure. Oh, Yautza. Yeah, Yautza on my team, who actually helped quite a bit with the tree workflow. Um, and yeah, so Sean started and Dale started talking to us about like, hey, like the process of laying out Silva cells is really arduous. And for them or for the designers who are designing them, and just getting that from like, this is a great idea, we want Silva cells here, to how the heck do we build this, is like a really huge thing. So we thought this was a great place for LandKit and Grasshopper to really help with this process by creating a workflow similar to some of the other workflows we've created. So just as a little context, Landau's team is relatively small. We do these kinds of um, workflows, digital tools, as well as visual storytelling. Our big mission is to empower landscape architects to accelerate their design impact, and this is a perfect example of that. We want to revolutionize landscape architecture, and sometimes this sounds like a hyperbole, but for stuff like this, I think it's dead on. To think at scale about how we can get trees into the urban environment as fast as possible, and and how to help landscape architects handle all the complexity of all the things that they're dealing with on a daily basis. Because who's got time for this, right? Who's got time to like do every like little crazy thing? It's just we don't have the budgets, we don't have the time to do everything the old ways. So we provide these tools and services to help solve these problems and to make design flexible and easy to do. So typically you're working from like a really basic sketch, and you build up CAD, and you've got to draw sections and think through all these things, and if anything changes, you're sort of out of time and money. So what we like to do is create continuous workflows that lets you manipulate a model and have a fluid digital model that you can change over time. And we have a set of plugins for this, and we're using some of this within the tree workflow. But this allows you to go from an idea sketch into kind of a fluid workflow, and then to get all of these byproducts out of it, hatches, sections, blocks, rendering. There's stuff you need for rendering, et cetera, et cetera. We're going to have some of that as well within this workflow. And we think people could, especially for things like this, they could start doing it earlier in the process to say, hey, like, is this actually going to work with all these Silva cells? We have all these utilities here. Let's like just do a quick study, right? And typically now, like, that's maybe really hard to do but with the new workflow, we're hoping to make that easier, and then to also be able to keep changing things further out into the process. So we have a number of different tools that we use and we're going to bring to bear here. Our planting, our paving and patterning to sort of lay out the cells. We have topography, which allows us to sculpt topography. And in this case, we haven't leaned into the topography design element in this workflow yet. But our idea is like we're going to bring in like an option to do like you know, more of like land kit grading as an input. But right now, all you do is you would just put the mesh, the topo mesh on a certain layer. And we'll show you that. There's all kinds of operations that we're using to build all kinds of tools. This is just one of them. We're doing things for paving and iterating paving. So this is a great, imagine these are silvacells, right? Like that, maybe not that many silvacells, but it scales, right? Like when you start to kind of build with these tools, they're algorithmic, you can scale them quickly and you can iterate designs and come up with really unique conditions, rationalize things, and start working on construction and output, right? So making things easier for output. We have students testing these things out, which is really amazing because it allows students to kind of get an early idea of how these things could work and build the skills before they show up at a firm or at a municipality or whatever. We have large firms like Design Workshop who are bringing their designs into 3D using LandKit and doing planting design and paving design. And imagine pairing this up with the tools that we're going to show you today to figure out where street trees go and grow. And that will be great. And then we have firms like Fido using these tools as well to help figure out designs, not just figuring out a design and then using the tools to make it in 3D. We're actually designing in 3D, and that will be also the case here for the tree workflow. So these workflows, we actually have a number of workflows for topo, paving, planting, and we've actually rolled the performance workflow into the topo workflow. And that it's become a very powerful workflow. So any topography concerns that you have like going into this, that are not addressed by the tree workflow, which because we don't really do very much with topo design, you can do all of that in this workflow and then bring that in. But the innovation with the workflows is that we have this very simple interface. So even though everything is built quickly in a Grasshopper script, we have the ability to share this with somebody who knows nothing about Grasshopper, somebody who wants to do these things but doesn't have the knowledge. And we can do that for paving and topo and rules-based planting design, and now soil cell design. We also have some workflows that are smaller that show you how these tools work. These are called mini workflows. It's like tutorials basically with a script that is included. This is a nice example of using a image to create a pattern. And so one last piece of context, which is that this year we've been really focused on heat and resilience. And really the star of that in many ways is our trees. And this is one of the reasons we really put the effort into this tree workflow, because trees are going to help us with urban heat islands. They're going to help with biodiversity and everything else. And if you can't get a tree into an urban environment, you're not using all the tools at your disposal. So we've created this heat flux calculator that helps to calculate the heat flux. We don't have that built into the tree workflow yet, but that it could be an opportunity there. And I'm not going to go into detail about that, but that's a new tool this year. And we're doing all these workshops for schools. So we did one for University of Nebraska and University of Nevada, Las Vegas. And those were heat islands. And this is University of Illinois, Urbana-Champaign. We're doing planting workshops. And I even went to Germany to do a workshop on food forests and thinking about, how trees and shade change over time. And we're thinking about dynamic environments. So, oh yeah, this is the fun thing. So imagine having plants change over time based on the new changing sunshade conditions of growing trees. So, one last piece of commercial break here is that we are going to make our lab licenses for schools, the first 30 seats free for all schools, and that's going to roll out in the next couple weeks. We've been busy with the tree workflow, so that's going to be available to all schools to offer to their students, and we'll have sign up coming at a first come, first serve basis. Okay, now that we've got all that out of the way, let's talk about sort of like pre, workflow and soil cell design. So typically, what we're trying to do with soil cells is um, maybe Sean can do the real brief. Sean, would you mind? Do you want to do the quick brief on this?
Yeah. Thanks, Chris, and thanks for your intro, and thanks for the kind of collaboration. You guys have done an amazing job here, and I hope everybody on the webinar, really appreciates the level of investment that you guys have made, not just in this plugin, but like just in what you're bringing to the industry. So it's super cool, and we're super excited to be part of it. Um, yeah, so I think most of the people on the call probably are familiar with Silva cells. I think we've jointly invited you. But in general, Silva cells are a structural system that supports paving and provides a space to add uncompacted soil to your planting area underneath the pavement, right? So we're providing this area underneath the pavement, a volume for you to provide uncompacted soil and often to manage stormwater, as you can see here from where Chris is moving through. And we engaged with Chris because what we realized was this unit that we have, which we have, 8 different heights, and is often deployed in dense urban areas where there's a lot of conflicts, and the work that you all take to lay out the Silva cells, to adjust them, to coordinate with civil, is a huge exercise and a huge time sink. And at the end of the day, really what you're after, what we're after, what we're all after is a consistent layout that provides the right amount of soil volume. And moving a cell 6 inches or 8 inches to avoid a water main, or having a slightly shallower cell to allow some type of utility to pass over it is not really, an expertise in design that any of us need to spend a lot of time on. It's in fact a pretty rote, like basic concept, but we all spend a lot of time revising these drawings. You spend them on the design end, we spend them on the shop drawing side. And so Chris and I were kind of kicking around the idea, and he was like, I think we could do this smarter. So that's where we are. And Chris, I'll hand it back to
Yeah,
you, but
perfect.
I think
That,
in
that
general, we're just making design smarter so that we can have more efficient and better landscapes in the future.
yeah, yeah, absolutely. Um, so we're looking at some basic things here. So when you plant a tree, you've got the root ball, but the roots need space to grow, and so you have your open soil area, but then usually we have on the sides are some kind of hardscape, whether it's concrete or paving or a road. And the Silva cells really support that. And you're probably, all of you here probably know this, but I just want to make sure. So a Silva cells, looks something like that. So we have to think about things like the excavation grade, the finished grade, how far down from the top of that grade are we going? Um, Obviously, where is the tree? What is the shape of the open soil area? And so this is actually kind of interesting because I was diagramming this and going, huh, actually, we'd maybe lay that out a little differently. But we have a tree pit here. So the tree pit would be the square. And then you're not always bringing, and you know, it really depends on what kind of structure you're trying to support. But um, the cells have to fill in to support the concrete around it, or the hardscape around it. And this might not be the best layout actually. And so you start to lay something out, you start at one end and you start laying it out and you go, oh my God, this is not right, right? And but like you're doing all this manually, right? So you're trying to lay it out manually and somebody goes, oh, actually we need 3 inch spacing, and you go, are you kidding me? I'm gonna like freak out. So this is gonna allow you to fix things like that dynamically. So imagine rotating your Silva cells and then saying, okay, actually we can get closer, etc. So that's the diagram. Let me get to the real good stuff here, which is the workflow. So um, so we have the Rhino file where we can bring in our CAD line work and import that. We have like a whole model here, but we don't need all of that, right? So I'm just actually going to turn that off. All we need is a top grade, and that could be just a flat surface that you're like, okay, I know it's at this grade, or it could be a mesh that you've created using a tin or LandKit topo tools or whatever. And then you need an excavation grade. So that could just be a copy of the grade from above, or in some cases, that's going to be a little different because you're on some sort of a landscape over structure or whatever. So you're actually dealing with two different grading scenarios here. But what you need to do is just have those as surfaces. Um, and then what we do is we say, um, provide the locations of each tree. And so we have that as point locations. We also are providing the the open tree pit area, which is going to limit where the cell goes, right? So if a cell sort of falls within that, we're gonna remove it, and we could, there's refinements. This is a caveat I'm gonna make right now. This is like the beta version of this. And so we're looking for you all to test this out, send us your comments, and we're hoping to improve it. We've got some ideas we're kicking around, but right now we more than anything we want to hear from the users. So we also can define a zone where these Silva cells are going. We can change all kinds of things. So let's have a look at what we can change. So let's start from the top with our parameters. So we can start with trees, and we can change, just the visualization of the tree. This is not a big deal, but you can make the tree bigger, um, you know, oops, wider, taller, whatever. And then we can change the max root radius, which we can talk about later when we get into the nitty gritties. But right now it's just set to a very high number. Um, we like to be optimistic about trees' ability to reach for what they need, as long as the soil is there. And then there's the root ball radius. So let me change our view modes here to solid so that we can see that root ball. There we go. So we've got like a root ball. We can just change how that's visualized, and um, the height, the radius, and then we have a target volume per tree, which we'll also talk about. So you saw all those colors. We're actually analyzing how much soil each tree has and telling you whether or not each tree has enough soil according to what you've asked for. We also have these other parameters here for soil cells. So we can do a Silva cell, or I can switch to Merino cells. Now, Merino cells are a little different. They stack, and they're more square. And so instead of having multiple cell sizes, like Silva cells have. Merino cells are the same size, and then you just stack them in order to achieve. Did it work? Hang on, it's thinking. So with this script, the Merino cells take much longer because there's so many more of them.
Hmm.
And I'm also running Zoom, which is always somehow, it's like the silver bullet for the computer, right? Um, and of course, we won't stay with Merino cells. We can adjust the spacing in between them. We can change what the pattern is. So it could be a grid of cells, or it could be this is it still, oh, there they go. Okay, so there's our Merino cells. So they're actually a little smaller in this case, I believe. And yeah, so let me go back to Silva cells because they're a little quicker. We're covering a lot. I think there's like 800 cells here that we're designing at once, right? With these Merino cells, which is incredible. So we're drawing a very few inputs. We've got like tree points, big boundaries for the whole corridor. Um, and we even have some utilities, which I'm going to be showing you. So if I, we also have this next thing is how to orient those cells. So if we look at it from the side, you can see how the cell is actually oriented according to the grade. So the install base option is orient to top grade. And if we change this to dead flat, um, it's a great option, but not for this sloping street, right? For the sloping street that's at whatever 5%. If we made it dead flat, here's what we would get. Let me zoom out here. It's gonna look for the like the lowest grade, and then it needs to find one singular dead flat location, and then it starts there and it builds that. And that's it. I think the ones we're seeing that are a little higher are across the street, possibly on the other side of the street. So that's a challenge there. So this orient to grade is to top grade is really important. And what it will do is it will orient according to each catchment or each cell placement area. So if your grade suddenly changes, like you might just want to break it at that location, right? So you can explicitly tell it. And that's the neat thing is you can start by one big area, but as you end up with these splintered zones, um, where you say, oh, actually, there's something limiting us there. We need to actually have another zone that orients the pavers in this other direction. You can do that. So we can change this top of cell depth, which is this, there's like 6 inches here. You probably don't want, I don't know how much soil you want on your tree. Maybe it depends on the tree. And then right now our cell rotation is constant, but we can also do custom rotations. So if I, I can see this. I can turn this custom rotation on, and oh, actually, the custom rotation is on. So you can see that these cells and these cells are oriented differently, right? And the way that we do that is I go to my placement area. It should be here. Is that? Oh yeah, it's way up here. So I can select that placement area, and I can launch this customize tool. I can click on rotation and I can say, okay, instead of 90 degrees, I want it to be 0 degrees, just like the other one. Hit return and watch down here. I should have framed it differently. You'll see that it will match the other installation a lot better. Should. Okay. Of course, it breaks during the demo. 0. Let's try 90 again. What have I done? Am I selecting the wrong thing? Cell placement area. It's constant. So let me try this. Switching between these really quickly. Again, this is sort of a beta. This is actually a brand new tool for us, this changing parameters of things. So it's out in beta in LandKit 2.1, but we have noticed a few issues with it. Um, but you can start with a constant rotation for your cells, but with the custom, you can select each zone. That's the idea. You can select it and then go and select the actual zone. Click on the parameter you want to change and change it. Hit return, and it should update, but it's not updating for some weird reason. Let me just look here. This is the workflow. You're welcome. Let me just launch that. It's just going to re-import that layer and get the keys and the values. So basically the data that we're storing in each piece of separate geometry, which is the custom parameters for that particular thing. So there we go. Now they both are doing the same thing. So that's 0. And then maybe we want both of these to be 90. It turns yellow if you have two things selected, just to kind of warn you that you've got more than one selected. So you know that you're changing all of your stuff all at once or something like that. So this is, we're going to do a 90-degree angle. And again, it's not updating. Okay. Weird. I hadn't had any problems with this yesterday, like 0. All right, maybe if I open the file fresh, it would be fine. So this we could also change like the thickness of the top plate if we're viewing in that more detailed view. But we have a few different view settings, so we can do a solid view and X-ray view, and then we can pick any color we want to sort of do this X-ray. Line work, which is a little bit more kind of shows you the whole cell. It's more atmospheric. And then a soil volume. Now the soil volume was really hard, but it's really awesome. So what it does is it says for each tree, create kind of like a figure out what the closest border is with the next tree over, and it uses the Verneuil pattern for those of you who are kind of into grasshopper, and then it calculates the amount of soil volume inside of the cell, and also this amount of soil in that more open area. It also looks at and then it groups all that together, and so you can see that this zone here is almost 1,000. 0 is going to be like where it's perfect. There's almost exactly 1,000 cubic feet of soil for that tree. But if it's orange, it means that we're low. So we're either between 200 and 400 cubic feet of volume that tree still needs. So this whole side is not, I think it's maybe just not as wide. And yeah, so that is really powerful. And if we were to go here and say, all right, well, what if we went back to the constant rotation and we have all our cells oriented in the other direction, where we have the cells kind of filling out a little bit more space. They're definitely more consistent, but we don't, so we're still working on the exact calculation of that volume, but it gives you a pretty good sense. And then we have sections, so we can turn the sections on. And what we're seeing here, I'm gonna go in plan, that's easier. So in plan, we can cut sections through the cell, through the tree, through the pit, or the root ball, and we get all this great information. And we're hoping to kind of like improve the look of this as we go. But you could like if you're designing with the topo workflow, you could use the same sections and sort of like you could cut through and then like line up data from different things together and have all kinds of wonderful documentation references to get your documentation going. We have got different, we're showing contour spacing here. We can change that. We have fast mode and um, detailed mode. So detailed mode, we zoom in, and this is one of the fun things Yaozi did was he built a parametric version of the cell. And so the cell will be drawn in there, right? As a 3D model. It's a little heavy, but if you're trying to create a detail or a model to illustrate something, it's a wonderful way to do that. We're also getting module counts. Now, because we offset all of this topography from the top to the bottom, we just have 500 cells that are all exactly the same size. And if we wanted to sort of look at this from the side and say, well, actually, over the course of this whole street, this is going to get narrower and narrower. So if I do a solid point on and select these points and say, okay, we're going to have less and less space here. This is actually going to get smaller and smaller from one end to the other. And what we'll see is a change over the whole thing. It gets redder and redder because those get shorter. But it also changes which cells that are being used. So it fills in cells that it can fit. So it's 2.5, 2 feet, 1.5, and 1 feet. So are there any questions at this point before I continue? I do want to show you the utilities, which allow a whole other level of coordination. You can see that here. For example, it's a very small example, but there's a pipe here that says like whatever your pattern was, there's a pipe here. So you can't put a cell here. Um, you can obviously do like custom things after the fact, but this will give you a really good, like, this will fill in a lot of stuff. If we go over to this other example, are there any questions? If there's any questions in the chat, oh, okay, it looks like we're getting some. We do have chat. Was there anything big in the chat, Ben, that you wanted me to answer?
Yeah, there's a great question here from Lyle. Apologize if I pronounced that wrong. Can the soil volume be different value for each specimen? So each maybe different tree species having different soil volume counts.
That's a great question. At this point, no, but I think we could pretty easily set that up. Yeah, currently that's not an option. Where, the way you might approach this at this point would be to say, um, yeah, I don't know. I think we might have to update that to make that work for you.
I can see a
Great
world
question.
that's possible that's not too crazy. Samantha also asked a great question.
Yeah.
I think is something that is a part of the annotations that maybe you're going to show here in a minute related to the different sizes of cells in plan view. So how do we know which cell is which size? And feel free to reframe the question, Samantha, if what Chris is about to show you doesn't quite answer it.
So for each cell, it shows what the soil depth was there. Like, and it goes all the way. I think this depth is actually calculated from the very top grade. This is something I'm just noticing, from the very top grade down to excavation. So it doesn't include that space in between. So that's one reason it's doing that. We've created, this is actually we've brought this excavation level really low here for this example. But you can do the soil volume for that cell, the soil depth, and the actual Silva cell that's being used. So here we have 2.5, but if I go over here where you can see I changed the grading in this area. Let me go over here. That we actually have shorter cells, 1.5. It's a 1.5, and then there's going to be 2 somewhere here. There's 2. Go down a little further, we're back to 2.5. Yeah. And then we have utilities. So you can see that we have these blue utilities running through. And those are going to limit certain things. So if I take this pipe here. And I take this pipe and I say, oh, somebody, why can't I select? I can't select it for some reason. Ben, would you mind demoing the utilities? I think I've had all three of these files open since last night, and my computer is starting to get a little angry at me with the Zoom and everything else. So Ben, I'll let you share here if you don't mind. And if it's too much, Ben, I can keep going here on my side. I'll keep going. Maybe Ben has
Sorry
two
about
dogs
that.
that are very.
Sorry about that. I
That's
had
okay.
a mute on. Yeah, I can absolutely already have it open, Chris, so I'll go ahead and share.
Go.
Um, and in addition to that, we had one great comment and another question about dealing with the top of structure elevation, like the below surface limitation. So the
Yeah.
ability to sort of change that sort of height, the top of cell depth. So Alayla, that top of cell depth here in the soil cell parameters is where you would adjust the drop below the top elevation to the actual beginning of when the cells start to be placed. So that would be sort of a limiting factor for what size cell you're using. And then I love that comment that was mentioned about the fact that some clients only can require 25% of that soil depth to be, or soil volume to be shared between tree species. So kind of awesome to see that we can maybe make that modification at some point. But you're kind of seeing a little bit of representation. I'm going to turn off a few layers here so that we're just seeing, some of the relevant pieces that we want to see here. But what Chris was talking about with the utilities, and we'll zoom in kind of on a smaller section here, is that you can see where we have these pipes coming through our actual utilities coming through here and actually limiting where cells can be placed based on those utilities. So having pipes laid out in particular ways. And then even if we go into sort of a top view and being able to see where we've aligned those pipes, we've just placed them sort of here in the plan view, and then we can actually adjust these pipes or the utilities in a variety of different ways. We can do so using sort of generalized set parameters where all the pipes are being set at a particular depth. So you can see here at the very bottom of the tree workflow, we have the utilities set in a tab called constant. And the constant parameters allow us to affect the pipes all equally. And those pipes are being just curves that we're placing in plan view in the pipe layer under utility pipe. And so all of these pipes are just a single curve in plan view aligned where we want that pipe. And then we're giving it a depth under which it is sinking into the ground to indicate that all of these pipes are at the same depth. And we're doing the same thing for channels as well. So you can see up here that we have a channel representation as well being created.
Maybe change one of those parameters for them, Ben. Like
Oh
maybe the
yeah,
pipes
absolutely.
get wider or
Yeah,
something.
let's get a slightly wider pipe here. Maybe let's go up to a 1 foot pipe radius, which is a bit intense. But if I'm like, oh, this pipe alignment's not actually quite right, I need to shift it a little bit further over according to our survey. And you can see just as I'm moving it around, it's not just limiting the placement of the cells, but it's also filling back in cells that are no longer being limited by that pipe. And so even as I shift these around into certain locations or adjust the Silva cells themselves, all of these limitations are going to be working together in unison to make sure that you're not running into issues with these pipes. And even
Yeah.
if I were to drop these pipes down to deeper depths, there might be possibility to fill in Silva cells over top of them as well. So there are definitely elements of that are pretty exciting to play around with and adjust a little bit. So I'm just like playing around with these a little bit. And there you go. You can see that. Now you can see that with the pipe being a lot smaller and at a deeper depth, now at 2.5 feet with a 5.5 radius, we now have the #1 Silva cells being stacked over top because the depths will allow it. So there's a lot of little fun things that you can do with this to make this work and incorporate these utilities in. Now, not all pipes are created equal and not all channels are created equal. And so we wanted to accommodate the fact that we're going to have different sized pipes and channels kind of working throughout the entire site. And being able to specify those is kind of important. And so we also have the ability to implement custom utility pipe parameters where we are able to select the pipe itself and utilize those same tools that Chris was showing before, where we can insert in custom pipe parameters. And with every pipe that we select, we can implement a specific depth and radius to it. So if we want to put a different radius for this pipe than the others, maybe this is a really gigantic pipe, maybe it's got a 1.5 radius, we can start to implement that differently from the others and start to create sort of a different representation of that. And, this is one of those brand new tools that we've added in. So it's possible that I might be running into some of the similar issues Chris was, but
Yeah, it doesn't work on Thursdays,
yeah, of course it doesn't. You can see it's adjusting all of them, but as we're making edits to this, the ability to adjust these, we've had a few tests where that works quite well, where we're adjusting different pipes at different sizes, and the same can be done as well for the channels also, where we're implementing different values, see top depth as well as height and widths of these different channels based on where you have them and the different values that you're placing on them, depending on the utilities that you're handling. Do we have any other questions that popped up related to this?
yeah, I should be monitoring that more closely.
Let's check.
No, it looks like Ben answered the most recent question.
What was some other parts of this that we wanted to make sure that we're showcasing a little bit here, Chris? Unless also Sean had any comments too as well. I just want to leave it open for everyone to get their thoughts in.
There is a question about sharing soil volume that's really interesting. I think we could certainly accommodate for something like that. Like maybe there's a parameter that talks about soil overlap. I think that could be possible. Because as you can see, most of the cells that I was drawing are like in the orange and the red. But it allows you, like Ben, if you were to turn on that soil volume, and here it's actually very fascinating in this particular example because it shows that like these 3 trees have like way more soil than they need, and so maybe you're gonna change the boundary of where you're actually putting the cells. This isn't just going to be drawn, yeah, you might make that smaller because it doesn't need quite so many. This one, it kind of nailed it there. And then, this guy's a little small. You might actually even consider like moving a tree over a little bit or whatever, right? Or maybe you say, hey, like I know that this is low and these are high, they're right next to each other, it's going to be fine, because like they're in the same pit together. Another thing we might want to do with the new like newer versions of this, subsequent versions, is maybe we show combined averages, but we wanted to sort of say, hey, like when these trees like butt up against each other, there's going to be like tree is going to have certain limitations.
Or maybe even a tag on each tree that says minus or positive percentage of soil relative to the value they've inserted in. So that
Yeah,
if you need to make that
yeah.
adjustment, say like sharing 25%, if it's missing 10%, but the trees next to it are dead on, then
Yeah.
it should be okay kind of deal.
Yeah. And
But clearly this zone doesn't have enough at this point. Yeah, go ahead.
I was just going to add in, like, I think, well, just to reiterate, I think one of the reasons we're having this webinar is to get these questions from everybody. And I think it's super
Yeah.
cool that people are like really kind of understanding what we're trying to offer. And Ben, I think you're sharing your screen, but like right here where you have the orange ones that are kind of not meeting the soil volume, what we see from our experience is like, okay, well, maybe there's just legitimately a reason why you can't get more soil there. There's a property line, there's a utility, there's a curb, whatever. Then maybe that's a tool that gives the designers a chance to say, okay, I need to put a smaller tree in here, or maybe this just isn't the best place for a tree. Can I get one bigger tree instead of 6 trees in here, and like that's the tool that I think you guys have developed that gives them so much opportunity to really kind of understand the importance of soil volume for the tree's success. And then, yeah, exactly. So if you got rid of that tree, I think you just did, Ben, now all of a sudden that one tree that's left is right in the sweet spot. So I think there's so much to do here. And one of the reasons we wanted to have this webinar is to get the questions, to get the users testing it out. As you said, Chris, it's beta. Like there's a lot more to come. And DeepRoot will be supporting this. And so, as these questions come up, we'll all work with you, everyone on this call and others in your office to kind of, provide better solutions and, evolve this tool. So yeah, I think exactly what you just did, Ben, is like, yeah, cool. Okay. Well, we can only get 6 trees here, not 12, but we're going to get the best 6 trees. There you go.
So just by making these adjustments, again, playing around with it live, this whole idea that Chris was talking about, designing in 3D with a product that you're trying to manage that can be challenging to lay out and make adjustments to when you run into an issue or a new design constraint is quite helpful. And now instead of like 8 trees, I have 4 trees, but at least all the trees have soil volumes that we're trying to hit.
Yeah, I think this also brings up bigger questions for me about like, are all of these rules of thumb like, what if I have other plants using the soil? Like, is
Yeah.
that's better for the tree, right? Or is that, but so there's always this conversation about competition. But we also are learning about trees and how mycelium can exchange nutrients between trees. So maybe if there's a tree that, I don't know, there's questions I think I still have in this process, based on, and a lot of this, some of the logic here that we've figured out isn't, top down from Sean. Like they've provided a lot of really great information, and we kind of have guessed at, as particularly the soil volume calculation. Um, and I think that's a bigger conversation we want to continue to have with Sean and DeepRoot, as well as like the broader audience here.
Yeah.
Yeah.
I just want to, while we're on this topic, I want to just add in 2 things that you guys have done that are just, I think, really useful. And then, Ishan, I can answer your question too. But, one of the important kind of features of the Silvacell is the ability to space it from 1 inch to 6 inches between each of the modules. And I think I'm correct in saying, Ben, that you guys have an ability to change that offset, right? So, if that offset changes, you're using potentially less Silvacells, or you're filling that space better with the same number of cells, instead of having to go in and lay out every one of those cells at different offsets. You can kind of grab them and do just what Ben did. Boom, you're done. You just maximize that volume without having to move and shift each little cell individually. And then the other thing is that, of course, they don't all need to be 90 degrees in their orientation, in their relationship to each other, because those pipes are not always going to go directly through on a axial basis, right? So there'll be times when the cells shift and they rotate, to fit in. And I think this tool does that really well. So anyway, I just want to answer Ishan's question about the 1,000 cubic feet. The 1,000 cubic feet is kind of the standard goal for a large street tree. If you're thinking about a 30-foot diameter canopy, where they're spaced 30 feet on center, the research suggests that 1,000 cubic feet of soil is kind of the goal. 13, 14, 1,500 cubic feet is better, and you see some of our projects that have been worked on, actually going back to Chris at Olin long time ago. Some of the projects like the Metropolitan Museum of Art or the Claude Cormier projects in Toronto, Sugar Beach, like those are exceeding that in volume. But that's the goal. And often we work with projects that have 600 cubic feet of soil. So I think Chris and his team just use that as a kind of a starting point.
Yeah, let me share one last thing here. So we did have one other example. I don't know if Ben included this or not. It's okay if he didn't. But this was kind of the file we were using when we were developing this. So, of course, I haven't opened the Grasshopper. Okay.
I also have
Yeah,
some
it's loading
other
Grasshopper.
files open as well, Chris, if you want me to just bring it up.
Oh, you do? Yeah, it's nice because I think I must have changed something last night with the custom parameters. I think that was my bad. I know I changed something and I thought I was fixing something, but I think I broke it. Um, yeah. So, um, but yeah, the custom parameters are going to be really huge. So like for every single pipe, you can change those parameters. For every single area that you're filling with Silva cells, um, you're doing a similar thing. And so for each zone, you can change that orientation. And if we have, oh, this is another thing I want to point out. This is like crazy. So if you have, if you've defined the Silva cells in plan and you've drawn this big shape and there's a pipe running across it and it separates, oh, okay, I've broken the whole thing now. Yeah. So if you run a pipe across the thing, it will not draw Silva cells in the area that's completely separated from the tree and by the pipe. So it's kind of a nice little bonus thing that helps you to see, oh, I'm drawing something in a space that's not even going to work at all. Like, okay, I need to change the shape of the space a little bit that where the Silva cells are going to fill in. Ben, I wasn't sure if you wanted to share
Yeah, sorry, I was just
that.
responding to a quick question.
Oh, okay.
Close out of this one. Okay. Try to share this really quick before
Yeah.
looks like a wonderful chaos. I love it.
Yeah, it's wonderful chaos. So like you could select, let's do custom rotation and select that larger area and rotate it so that it like orients more to the pipes. Also in plan, you can see that there's no Silva cells drawn here, even though that's part of the zone. Yeah, I've clearly broken this thing. You can rotate, you can just do the regular thing and just rotate just constantly for the one, just to show how we can rotate. So, um, you know,
That's
yeah,
amazing.
it's all connected. It's all connected. And if these pipes drop down, suddenly there's cells that can go here because of the depth, right? So we can fit that, 1 foot cell above the pipe. Yeah, there we go. This one got dropped down. So we've given you the files. We're probably going to upload this video and have like a new version that'll have things fixed. You want to watch for that. It's using LandKit 2.1 or higher. If you want to use, Ben, could you open the package manager real quick? If you want to use LandKit 2.1 for this or for whatever reason, you can do that by clicking on pre-releases here at the bottom. So include pre-releases, and then there's LandKit 2.1 beta 1 is the one you want. And that has a handful of new features that we're going to be more officially launching in a bit. But this workflow does use a few of these features. So particularly for the custom application of data.
And some of the little bugs that you noticed in here today while we were testing things out, we're going to make sure we get those sort of resolved for
Oh,
at
yeah.
least the things that we were talking about. That way that if you are wanting to start testing this out with a project and using some of those custom parameters, we'll include that link for a new Dropbox download with the updates in the video recording that comes.
Yeah. Are there any last minute questions here before we let you all go get back to doing amazing work?
Mhm.
We look forward to hearing from you either way. And and if you have other questions, obviously about LandKit and Silva cells, you know where to go. So
Yeah, thanks, Chris. Thanks to your team. It's we're really excited to continue to support this and develop this with you and support our customers as well. So thank you.
yeah, thank you all. Thanks, Sean. Cheers. Bye, guys.
Okay, thanks.